In this video, we are going to look at different techniques of solving quadratic equations. So there are a few varied techniques. So factorizing method, two techniques, quadratic formula, completing the square, and then completing the square using dots and the axis of symmetry. So we're going to start with a very easy example of a quadratic. So I've got a quadratic which is x squared minus 9x plus 20. Now I can clearly see from here that the sum is negative 9 for the factors and the product is positive 20. So the two numbers that will satisfy that condition is negative 5 and negative 4. So negative 9x, I need to write that as negative 5x and 4x, or I can factorize it straight away as I've done. So x minus 5 is one factor and x minus 4 is the other factor. And then while solving it, I equate it to 0. So that gives me x equals 5, or it gives me x equals 4 using the null factor law, whereby I put x minus 5 equal to 0 and then solve it for x. So that's the condition that will make it 0. And likewise, for the other factor to be 0, x should be equal to 4. So that's the very basic example that I took up. Next, what I'm going to do is to take the same example, but I'm going to extend this problem further by changing the polynomial coefficient. So a now is going to be 2, b is negative 9, and c is 10. So the sum is still negative 9 and the product is still 20. It's 2 times 10, which is a times c. So that's going to be 20. So my factors actually are still going to remain the same, but obviously the process I'm going to follow this time is different, because the first term, which is 2x squared, the coefficient obviously for x squared is 2. So m is still negative 5 and n, my second number, is still negative 4. So I'm going to use these two numbers. So negative 9x now, which is my middle term, has to be written out as negative 5x and negative 4x. So you can see that. So negative 9x has been written as negative 4x and 5x. I'm highlighting that so you know what I'm exactly doing. All right, now what we need to do is group them. So 2x squared minus 4x, I'm going to group, take that as my first group, and then negative 5x plus 10 is going to be my second group. So I'm just grouping them. And once I have grouped them, then I'll see if I can take a common factor for both these groups. So if I look at the first group, 2x is a common factor that will leave me with x minus 2. And in the second group, if I look, negative 5 is my common factor, which also gives me x minus 2. So now 2x minus 5 becomes my first factor and x minus 2 becomes my second factor. And now if I equate this to 0, it will give me the solutions. So 2x minus 5 equals 0, or x minus 2 equals 0. If I solve the two using the null factor law, I should get 2x minus 5 equals 0, which gives me x equals 5 on 2. And likewise, if I look at the second factor, x minus 2 equals 0, that gives me x equals 2. So that was just factorizing them out rightly and using the middle term and the two numbers negative 5 and negative 4. I use them to actually split the middle factor. Now it's going to be a similar approach but with a slight difference. So I've got 2x squared minus 9x plus 10. It's exactly the same question, no change. So m is still negative 5 and n is still negative 4. Those are the two numbers that satisfy the condition. But actually I'm going to follow the normal process over here. So I'll write that as x minus 5 into x minus 4. Then the coefficient of the polynomial is 2, or the x squared term is 2. So I divide both the numbers, negative 5 and negative 4, by 2. And then I simplify that. So x minus 5 on 2 cannot be simplified, whereas x minus 4 divided by 2 simplifies to x minus 2. In the next step, from the fraction part, negative 5 on 2, I move 2 to the other side, as you can see. So 2x minus 5 and x minus 2. And this is going to be actually, it's pretty much the same that we had in the previous example. And now if I solve this, it should give me my solutions. So this always works. At times students are hesitant in using this approach, but this always works. So let's look at another method. Now this is a turning point form. Turning point form actually at times is very helpful, and I'm going to write this with a common factor 2. I've taken that out. So axis of symmetry we know is negative b on 2a. In this case, b is negative 9 on 2 after I've factorized that. So as over there is the axis of symmetry. So it's x minus axis of symmetry square plus there's a horizontal translation, and of course 2 was the polynomial coefficient of the x squared term. So all I do is I go and substitute, and then 9 on 4 is the axis of symmetry. Now I also knew when x was 0, y was 10. So if I go and substitute that, it should give me the value of h. So now I'm solving for the value of h. If I simplify this, 9 square is 81, 4 square is 16. And if I times that by 2, and we know that's equal to 10. So now I'm trying to solve for h. So which will be 160 minus 162 over 16, which is 2 over 16 with a negative sign. It simplifies to negative 1 over 8. So I get the value of h. Now this gives me the equation for the quadratic in the turning point form. Now once I've got the equation in the turning point form, actually if I look at the, yes, so I've put a positive there, so positive, and then the vertical translation is negative 1 on 8. Now if those two signs are opposite, the solutions will exist. If those two signs are the same, then there'll be no solutions. So in this particular case, obviously the solutions exist. So I'm going to solve it for 0, the turning point form equation. So 0 equals 2 into x minus 9 over 4 whole square minus 1 over 8. So 1 over 8 now I've taken to the other side, and now I'm solving this. And now if I take the square root on both the sides, so I move the 2 to the left hand side, and then I'll take the square root on both the sides. So positive and negative square root of 1 over 16, which will simplify to positive and negative 1 over 4. And on the other side, I've got x minus 9 over 4 now because I've taken the square root. Now I'm going to solve for x. So I'll move 9 over 4 to the other side. So it's going to be 9 over 4 plus and minus 1 over 4. And now if I simplify this, this should give me the two solutions. So the first solution with the positive 9 plus 1 is 10 over 4, which simplifies to 5 over 2. And then of course, then I take the negative, which will be 9 over 4 minus 1 over 4, which should give me 8 over 4. And that should be equal to 2. So this is using the turning point form. So turning point form at times is actually very helpful. Often a mistake students make is when they are given the question in the turning point form, they expand that out. Okay, let's look at another method, same question. So up to here is the same steps that I did for the turning point form. So the axis of symmetry is 9 over 4 plus. Now I go, the solutions are the axis of symmetry minus z and 9 minus 4 plus z. So we know that the two solutions lie on either side of the axis of symmetry at the same distance. And we are equating this equal to the y-intercept, which in this case is 5. So from there, so y-intercept is 5. So in this case, the y-intercept is 5 after having taken 2 as a common factor of the quadratic. Now using difference of two squares, I can write that as 9 minus 4 square minus z square equals 5. So I've just put a vertical line because I'm solving the part on the right hand side of the line, and later on once I've done calculation, I'm going to add 9 by 4 to get the solutions. That's what it simplifies to. Now I move 5 to the other side and z square the other side, so it's going to be 81 over 16 minus 5 equals z square. Now if I simplify that and find z, so that's going to be 81 minus 80 over 16, which is 1 over 16. So z is going to be the positive and negative square root of 1 over 16. So you will see it is very similar to what we did with the turning point form. So that's going to be plus and minus 1 over 4. And now all I need to do is to go and add this to the axis of symmetry, which was 9 over 4. So my first solution will be 9 over 4 plus 1 over 4, and the other will be 9 over 4 minus 1 over 4. Now this is actually a very easy method. If you have practiced this technique a few times, you'll find this actually very helpful, and it's a very quick way of getting the correct solutions. So I get the two solutions. So I highly recommend that you practice this method with at least 4 or 5 different style of questions, and it will always work. All right, lastly, we are looking at the quadratic formula. So that's the quadratic formula on the screen. So A is 2, B is -9, and C is 10. So all I need to do is to substitute these values in the quadratic formula. Negative of -9 changes it to 9. So 9 plus and minus B square is 9 square minus 4 times A times C, which is 8 times 1080. And so it's 81 minus 80 over 4, and 81 minus 80 will be 1. Square root of 1 is 1, so it's going to be 9 plus square root of 1, which will be 1 eventually, over 4. So again we are back to 9 plus and minus, and it's over a common denominator 4. Using positive 1, I get x equals 5 on 2, and the other solution would be x equals 8 on 4, which would be 2. So 5 on 2 and x equals 2 are the two solutions here. So as you can see, my first solution is x equals 2, and when I use the positive value, it's x equals 10 over 4, which will give me x equals 5 on 2. So those are my two solutions. I'll quickly talk about the usefulness of the turning point forms. I've got 4 examples over here. The first example, the quadratic is negative in nature and it has a vertical translation. So I've highlighted the signs. If the two signs are opposite, the solutions exist. And if the two signs, that is the quadratic sign and the translation sign, are the same as in the second example, there will be no solutions. Likewise, if I look at my third example, the quadratic is positive and the vertical translation also is positive. So I'll go and put a plus in front of 2. So the two signs are positive, so there will be no solutions in this case. So actually the quadratic is a very helpful way of determining whether the solutions exist or no. So let's look at the last one. The quadratic is positive, so it's positive 13, and the vertical translation is negative, which is 11. So opposite signs, so the solutions will exist. Thank you for watching this video.